So, how many of you had the misfortune of reading the blog post that I did? I think it was posted around about July or something like that, which was entitled something like, "Is there anything else we can help you with today?" It's rather long and verbose, but it was kind of inspired by conversations with a couple of customers who were having kind of a shared problem. And that problem was really about getting information, getting data off of their OpenVMS systems to somewhere else where they could do something useful with it. In one case, this was more around observability. So what is actually happening on our system? Observability, traceability, metrics collection, things like that. In the case of the other customer, it was more about their system was very batch-oriented in terms of its processing, and they could actually, improve their business, improve their agility if they could do things in a more near real-time manner, if they could escape that batch-oriented mode of operation and move to more of a real-time mode of operation. And these discussions kind of triggered crazy ideas and resulted in the development of a prototype solution that I'm going to talk a little bit about today. But first I'll bore you with some background leading up to that. And then we'll do a little bit of a demo of some of the things that have been incorporated into the solution that we're working on. And hopefully you'll find at least some of it somewhat interesting. So, as I say, just a little bit of an introduction, some terminology and so forth. Then we'll look at, just very briefly, at some of these common data sources on OpenVMS that customers often ask about and they're interested in. They want to load that information into some central repository or whatever, log files, auditing, accounting, etc. Look at some of the challenges of doing that, and then we'll start talking more about how we can solve these problems. Then I'll focus a little bit more on the change data capture area, which is more around that shift from batch to near real-time processing, dealing with RMS files and things like that. Also try and catch Hein's talk and Brian Schenkenberger's talk. Hein and Brian will be talking a little bit about change data capture as well. Summary and future plans. So first of all, introduction. So what we're really talking about here, and I noticed a mistake on my slide pretty much straight away. This should not be more analysis, data collection, analysis, and doing stuff with what we've analysed. But essentially what we're talking about here in terms of improved visibility is something that the industry refers to as software telemetry, right? And I've entitled that there, or defined that there, as the automated collection and analysis of software data for insights into performance, usage, and behaviour. Okay, so this involves collecting lots of different metrics that one way or another allow you to achieve the goals and aims that I've listed down the bottom, right? You're going to collect performance data, you're basically going to collect data around usage patterns, how people are using software, collect information around errors and exceptions, operational events, whatever. You're going to trawl log files. You're going to gather all sorts of seemingly disparate information, come up with some correlations, do some analysis, use all this information to actually improve your users' quality of life, streamline your IT operations, streamline the efficiency of your software and so forth. As usual with the software industry, kind of a trendy name for something that's maybe not so trendy. A little bit more detail. I won't read through the paragraph there because I've kind of said that already. But the sort of information you're looking at, to dig a little bit deeper, you may be getting some data on things like, how efficient are our programs? Have we got enough resource in there? Are response times adequate for the user's needs, or is things taking too long to respond? Application crashes, general stability, log files of certain things that are happening on the system and so forth. System data, application data, you name it. You throw it all into the mix. So what do you do with this stuff? As I say, you can analyze it and you can improve the user's quality of life, make the user feel better about using the system, make the system more user-friendly, make it more efficient, more performant, identify and resolve proactively any security-related issues. Essentially, you can use this data, this supposedly disparate information, for informed decision-making, right, to improve how your software works, how your applications work, and how users interact with them, and so forth. Now, how do you collect all of this data? You can stick statements in your applications to trigger events. I mean, how many people here remember or ever used Oracle deck trace? Well, I'm sure Kevin did. He's still in the room, but this sort of thing is not new. I mean, Oracle or Digital introduced deck trace back in the early 90s, sold to Oracle, part of the RDB acquisition around 1994. So this is not new stuff, right? People have been collecting these sorts of data for decades. But what's happened probably in the past decade is there have been considerable advances, technological advances, cloud-based services, centralized solutions into which you can chuck all of this information. If you look at something like deck trace, it collected data and it stored that information in Oracle RDB. You could then run reports and queries and draw some conclusions. In the modern world, that data is going off-platform. It's going into some centralized repository like a Dynatrace or Splunk or Elasticsearch or something like that. You can load all sorts of data. It doesn't have to be, just numbers and timestamps and things like that. It can be raw log files and so forth. And these centralized solutions can gurgle away and analyze this data and allow you to query that information and make informed decisions on how your applications and systems are performing. Okay. Some things I've mentioned there from a VMS perspective, log files, ACMS logs, the audit log, accounting logs, web server logs, T4, these are all sources of potentially useful and interesting information. Change data capture, we'll talk about that in more detail later. Capturing changes to index RMS files or indeed sequential files, doesn't matter. Okay. So, moving right along. So, if we look on OpenVMS, like I kind of indicated on that last slide, there are, the photographers in action. There's a lot of interesting data, even on the most basic of OpenVMS systems. But, you've got accounting, audit, and system error logs. You've got OPCOM messages. Okay, they're probably going to show up in the audit log as well. Customer applications or layered products, I should say. ACMS creates audit logs. It creates event logs. Applications create custom application log files. Web server creates access and error logs. Every time you make an HTTP request to Apache on OpenVMS, there's going to be something in the access log saying that, someone went to that URL, whatever. There's a lot of information. T4 collects a huge amount of information using Monitor and various other bits and pieces. All of this information can be collected and can be of use to people. You think about how you use T4 today. T4 is really widely used. How do people use T4? They create CSV files, they copy those CSV files to their PC or something, and they mess around with them and they create pretty graphs. Well, that's great, but it's not real time, not at all, okay? So what are some of the challenges? Most of these challenges are fairly boring. If you look at OpenVMS, sadly we don't have some of the agents that you can get for Windows and Linux for, say, Splunk or Dynatrace or some of these other packages. OpenTelemetry and Prometheus are two technologies that you can use for, say, instrumenting your code, right? These products provide client APIs. You can put calls into your applications, much like you would with deck trace, and actually use those calls to track how your application is performing and collect that data. We don't have OpenTelemetry on OpenVMS, to be honest. We can probably do that on x86 now that I think about it, because we've got a higher level of C++ language support. Prometheus, very common open source technology for monitoring and so forth. We do actually have a client API on OpenVMS for Prometheus, and that's hooked into, for example, our VMS SPI tool, and we'll see a little bit of that later on. So, having the tools and bits and pieces that you need to do some of this stuff on OpenVMS is an issue. People always worry, well, okay, there's no free lunch. You go and install these tools, you go in and put in these hooks in your code to collect data. Am I going to impact performance in some way? Well, yes, of course you are. But generally speaking, the performance hit that you get with this stuff is fairly minimal. I'll talk a little bit more about that later on as well. I will get customers saying, "Hey, look, we've got Splunk all hooked up. We're loading in log files from our Linux and our Windows system. Can we load the accounting file from OpenVMS into Splunk?" Sure, it's not going to be able to do anything particularly useful with it, right? That's an indexed RMS file with very complex record structure. You go and throw that thing into Splunk and it's just going to go, okay, and you're not going to be able to get anything interesting. Daria.
I just need to press one button. I'm so sorry. Keep going.
Okay.
Well, we need to flip the screens.
Need to flip the screen.
Yes.
Yeah.
There was some... Keep going. I'm sorry.
Oh, I'll just slurp on my coffee. So yeah, you can't take those files like the accounting log or the audit log or whatever and just load them directly into something like Splunk like you would with log files from, say, a Linux or a Windows system. It doesn't work that way. Okay.
Can we do this? Or do you need presenter view?
I don't like presenter view. I hate it. So that's vastly superior. Okay, so how do we solve these sorts of problems? And just a little note here, has anyone actually had a look at the record structure in some of these OpenVMS files? Right, it's painful. Okay. Like I say, you can't just pick up those binary files, the RMS audit log or the accounting file, and throw it into these modern tools like Splunk or Dynatrace. It's just nothing good is going to come of it, right? The other thing around software telemetry is, well, let's take a hypothetical example. Let's say a customer's got some sort of web service interface to their ACMS application. User makes a request, HTTP request comes into the web server, that triggers something to happen that communicates with ACMS. The ACMS task runs, results get sent back to the user. Great. How do you correlate those things? How do you correlate the HTTP request with the ACMS task ID, for example? You need some way to actually correlate all of these little bits of information so that you can actually query all of that data and make properly informed decisions. Correlation is a pain in the butt, and to some degree you can do things like use timestamps, but that assumes that timestamps are accurate everywhere across your business, across your entire enterprise potentially. That web service request might have come from some Linux system. It might not have even been a user. If the time is different on one system than on another, timestamps aren't going to be terribly much use to you. You can build in correlation IDs, some sort of magic number that you can use for tracking requests as they gurgle through the various components of your application environment, and so forth. There are other ways you can do it, log aggregation and so forth. I mean, again, that generally comes down to making sure you've got common timestamps and things like that. But correlation is always a challenge, and I'm not going to try and solve that today because it's a bigger problem. One of the customers I was talking about, as I say, wanted to get a lot of this data, accounting data, ACMS logs, HTTP logs, etc., off of OpenVMS into, I can't remember which, it was Dynatrace or Splunk, doesn't really matter. We don't have agents on OpenVMS for Splunk or Dynatrace. And like I said before, there are other limitations where some of those files, even the ACMS logs, contain binary data. They're not text files that you can just go and throw into these tools like Dynatrace and Splunk. And the record structure is not only complex, but it uses VMS-specific data types. Okay. So this got me thinking, how can we solve this problem? What occurred to me was actually really, really simple, because I like simple ideas and I'm a fairly simple sort of person. The cunning plan is almost trivial. It's, okay, so we don't have agents that run on OpenVMS to collect this data, but we can provide tools to shuttle that information off of OpenVMS as quickly and as efficiently as possible in some format that can then be ingested by the customer's tools, right? So what we will do is we will develop some tool that in near real time can gurgle through these log files or whatever, and could convert records if necessary into, say, JSON documents or JSON records, whatever you want to call them, and push them into some sort of message queue. When the data's sitting there in the message queue, the customer can then write their own tools. They can do it in Python. They can do whatever. Quite often these products like Splunk and Dynatrace have consumers that can consume from message queues anyway, so it doesn't matter. We get the data off of OpenVMS and put it somewhere where it's easy for the customer to do anything they darn well want with it. You know, we don't care. Our responsibility is ended at that point. There you go, Mr. or Mrs. Customer, do what you like with this information. Okay, over to you. So that was the plan. And Nikita's come up with another name for this thing, but I like to call it Vol, little furry animal. For some reason or other, whenever I prototype a solution, they're usually named like after furry animals of some description, whatever. But anyway, so we developed this little prototype Vol solution that allows you to do things. Essentially, it provides functionality to monitor almost any sequential log file in near real time. And read the records from those sequential files as they appear. Okay, so some examples there. A new record is written to the ACMS audit log. Right, Vol will pick that up, do something with the data, and push it out to an appropriate message queue. Okay, to date, Vol is able to consume built into it out of the box the various data sources I've listed there. But Vol is also readily extensible via shareable images. If you've got some wacky file format that your application uses, you can write your own little shareable image and hook that into Vol. He knows how to use it and push the data into the message queuing system, etc. A few extra bells and whistles, common intrusion messages, can actually hook into Oracle Log Miner as well and do stuff with that information to essentially change data capture for RDB. And thanks to some code from Hein, we can also hook into RMS statistics in real time as well, so you can actually monitor what's going on with some number of RMS files that might be of interest to you. It also knows, for example, if it's reading something like the ACMS audit log and the system manager goes and creates a new version of that log, Vol knows to transition to the new file and carry on processing once it's finished the current file. So, like I said before, I mean, the way this thing works is painfully simple. This is a script from Vol. Vol understands VMS like, CLI, syntax, etc. So we're going to connect to our message broker. We're going to monitor a file. In this case, it's monitoring the ACMS error log, swl.log. And we've defined some information in here, which I won't bore you with, which specifies how it's going to be published into the message queue. I've specified an interval of 5 seconds, so it's actually going to check for new information every 5 seconds. And the callback thing is the key, right? So this is the extensibility aspect. In this case, vol$swl.exe, that shareable image knows what to do with records that are read from the ACMS audit log. It knows how to transform them into something that's readable by a human. So for every record that is read from the ACMS audit log, that shareable image gets a function, and that shareable image gets called, transforms it into, I think, a piece of JSON or something like that, and that information is then published to the message broker, whereupon the customer can consume that information and do with it whatever they like. So looking at this in a pictorial sense, Vol is sitting there consuming information from these various data sources. It does so in a multi-threaded fashion, so you could have a separate thread consuming from Apache log files, another thread consuming from one or more T4 files, etc., etc. And those records are converted if they need to be converted. Obviously, web server log file records don't need any conversion, they're just simple text. They're published to the event broker, message queue, whatever you want to call it. And then, like I say, the customer can do their own thing from that point on. We don't really care. So just for example here, so in this case I'm publishing the data into RabbitMQ instance. You can see there that this isn't live, obviously, it's PowerPoint. But there's, like 2 million odd records that I've read from the Apache logs, and a few records I've read from ACMS logs, and so on and so forth. So this is all data that's getting queued up, and you could then consume it, load it into Dynatrace, do whatever you like with it. So simple example here, again our ACMS log, data is being consumed, actually in this case by a service that we provide anyway, actually as part of our change data capture solution, which I'll talk about later. These ACMS error log messages are published into the message broker. We have a consumer process which is reading those messages, converting them into SQL statements and inserting them in this case into a SQL Server database. You can then write little queries and do an analysis on this and see that Brett Cameron queried this task by product. I obviously drink a lot of coffee. This is my coffee shop demo from previous bootcamp. These are all the tasks that are called. This is when it started, this is when it ended. So you could actually analyze from this how long tasks are taking to complete and so on and so forth. Right? So that's a trivial example. ELK stands for Elasticsearch, the three products that make up the Elasticsearch suite. Elasticsearch itself, which is kind of a database and search engine. Logstash, which is quite a clever little thing which can consume information from the event broker. And Kibana is something you can use for creating pretty tools. So in this case, the graph down here is some T4 information that's coming through in near real time, give or take, maybe 5, 10, 15 second delay by the time it gurgles through. But this is Vol in real time, reading T4 data, pushing it into the message broker, Logstash consuming that information from the record broker and pushing it in, storing it in Elasticsearch, and then Kibana being used to create pretty graphs. Okay. Another variation on that same theme is a demo which I'll show very soon, if the demo gods are willing, and AWS is still running. But essentially in this case what we're doing is Vol is consuming data from T4, it's publishing that data into the RabbitMQ message broker, and then InfluxDB, which I'll talk about on the next slide, is a high-performance time series database. So it's optimized for storing time series metrics, essentially. So a tool called Telegraph provided by InfluxDB is used to read the information out of the message broker and store it in InfluxDB, and then Grafana allows you to create the pretty graphs. And I'm absolutely dreadful with Grafana. It's easy to use to create simple graphs, but Liam, if he's around, is the expert when it comes to creating far more sophisticated and pretty looking graphs. And Grafana is commonly used with Prometheus, and we'll look a little bit at that later on as well. So InfluxDB, I mentioned, it's a time series database. I mean, this thing kind of came out when Internet of Things, shall we say, became fashionable, became a thing. And there was this spate of companies creating time series databases. So InfluxDB's probably been around now since, I think I first got exposure to it maybe 2011, 2012, something like that. It was fairly immature at that stage. But it's a pretty well-established time series database, and I think probably one of the better ones. Provides a lot of little plugins, integrations, whatever you want to call them, for hooking into things like Grafana, consuming messages from various sources, message broker, whatever. Lots of client libraries. Nice and simple to use, really. Simple to get the data in, simple to get the data out. So this demo, if things are working, kind of hangs together a little bit like this. We're going out the Grafana route here, where essentially Vol is doing its thing, reading T4 data, publishing it into a cloud RabbitMQ instance. That's getting consumed by Telegraph, and that's publishing it into InfluxDB, and Grafana hooked straight into InfluxDB. So if by some miracle I click on this link below, when I can find my mouse, we might actually see something. Okay, so this is some T4 data coming through as I say, in near real time. I mean, the delay will be caused by, firstly, how frequently records are actually flushed by the T4 system. Secondly, that I'm checking for new data every 4 or 5 seconds or whatever, and then it's going to gurgle its way through the system and come through. But that's, say, 5 or 10 seconds is a lot better than, say, waiting until T4 finishes at the end of the day, creating your CSV files and then plotting them in Excel or in TLViz or whatever. So, I can click the refresh. It's on auto refresh every minute. Doesn't matter. I'm not sure how much data I've got in here, but I think I can go back in time. I'm not sure about 90 days, but I can certainly do 30. So at this stage, it's pulling all these data points out of InfluxDB and pulling them up in Grafana. So this is kind of, if I made it maybe 2 or 3 days or something like that, you'd kind of see what Brett's work pattern is, right? You would see when Brett's at work and actually doing stuff and running programs, because there would be some CPU usage or whatever happening on the server. Anyway, as I say, they're very, very simple graphs created with Grafana. You can do that fairly quickly. Okay, so that's the first demo. Phew, one of them's worked. Just a note of personal preference. I actually prefer this approach to the ELK stack that I mentioned previously. I think I don't like the graphing tools in Elasticsearch. I find them much harder to use, so that's probably just me being thick. Grafana, I can create something really quickly and easily. It's not rocket science. I didn't have to read the manual. That's the key point. Okay, Prometheus. So I mentioned Prometheus before as a very popular open source product for monitoring and alerting. Okay, and again, it includes a time series database and things like that. But the way it works is really simple. Essentially, what you've got in our case on the VMS system is a web server that basically you can go to the web page yourself, and it's just a simple text output of metric A and what its value is, metric B and what its value is, metric C and whatever its value is at that particular point in time. So essentially, Prometheus is scraping a URL. It scrapes URLs, and those URLs return a pile of metrics, stores those metrics in its database, and you can then use tools like Grafana to plot that data. So I won't go through all of this, but essentially this is what I described. You configure Prometheus to know about these different URLs for whatever systems or applications you've built the hooks into. Prometheus goes around and it scrapes all those URLs, stores the data. You can then use your visualization tool to draw some pretty graphs. So this again is my very simplistic line time series plots with Grafana. Our VMS SPI product in fact has this built into it. It is in the documentation. So if you're interested in this sort of stuff, you can configure this up, install VMS SPI on a trial license. I think it's 30 days or something. You can get this running in a few minutes. It's not a big deal. And VMS SPI is primarily, designed to detect problems on your system and report those problems. And it can send those messages to all manner of different systems like Splunk, Dynatrace, PagerDuty, wherever you want the information to go, or it can send you a boring email. It doesn't matter. But as a consequence of doing that work, it obviously needs to collect some metrics. So what we've done here is we've actually exposed a subset of those metrics using the Prometheus mechanism. So once again, if the presentation gods are with me, we might be able to click on this link and display something. So this will probably look strikingly similar to the other graphs, but I think, well, this is kind of cool. So this one's obviously disk space, so I've got something running on there at the moment. I thought I should generate a bit of a workload, right, just to make it look more interesting. So I set a few batch jobs going to do compiles and things like that. So I'm not sure why the disk usage is generally increasing, but you could tell it's done something, deleted something, done something, deleted something, etc., etc. But much the same as the previous graphs, just a different way of getting the data there. Okay. So lots of words, not going to read them all. Key points. My ability to create graphs with Grafana is very limited, but it's an incredibly powerful tool for producing these sorts of graphs. You can do all sorts of fancy stuff. You can also hook it up to help with alerting, thresholds reached, boom, someone's going to be told that bad things are happening, etc. I mentioned before, I talked a lot here about near real time. The rate at which data is flowing through this system with Vol, like I say, it's not really real time, it's pseudo real time. There are limiting factors, how frequently files get flushed and so forth, how frequently we're actually looking for new information to process and things like that. Thilo, many of you will know Thilo, our colleague in Germany. Thilo thought this looked cool, but he was very concerned about the Heisenberg principle and whether the act of making measurement might impact the result. I had to assure Thilo that this system does not actually consume an awful amount of resource, and this is kind of what I describe here. If you start Vol off and it's got a whole pile of data to process, then yes, you are going to see a short-lived operational spike. You know, I had the graph up there before where there was something like 2 million HTTP access log records in the message broker. Obviously, reading that access log file is going to consume some time and some resource. But generally speaking, you know, if Vol starts up and it does have a lot of work to do, it's a short-lived operational spike, and then you get into kind of steady state mode, and the impact is almost unnoticeable. Change data capture. So, as I say, go to Brian's talk and go to Hein's talk. Hopefully they're not booked at the same time. But Hein, that'll be Camille's fault. Brian and Hein know far more about change data capture than I do, and indeed we couldn't probably be having this conversation without Brian's contribution anyway. But just in terms of change data capture, just some background, the principles. The concept is very simple. You make a change to a database record or a change to a record on an RMS file. You want to capture that change in real time essentially and do something with it, right? This gets back to the batch scenario that I talked about earlier, that the customer was kind of lamenting the fact that their system was very batch oriented. So they would have to wait until all this information had been gathered for the day, and then they'd run a batch job overnight, and then the following day they could figure out what inventory they needed to ship where and things like that. If they could have done that in real time, it would allow their business to be much more efficient. Now, historically, it was done in a batch mode because, you know, 30 years ago when the application was written, that was the way you did things. You had to, resource constraints, etc. These days, you could do that in real time using change data capture, right? So it's a mechanism for capturing those changes as they're happening and doing something with those change records. There might be multiple reasons why you want those records. It could be integration, it could be fraud detection, it could be anything like that, okay? So we're going to monitor for these changes, we're going to intercept these changes, and we're going to do something with them. Again, in true Vol, the way Vol works, it's going to publish those changes to a message queue, essentially, right? And again, we're pushing the data off of VMS as soon as we can into the event broker, message queue, and customers, users, whatever, can consume that information, do what they want with it. We don't care, go for broke. Okay. So, like I say, there are many benefits to doing this, getting out of that batch mode and into more of a real-time mode of operation. Auditing, as I say, fraud detection or something like that. You know, what is going on in my system? Why did somebody make a change to sysuaf? Potentially you could use it for file mirroring, or detecting some strange behaviour in your application or whatever. And a very key point here, that there are a large number of OpenVMS users, some of you may be one of them, that store application data in indexed RMS files, right? It's more common than you might realise. Okay, so just talking a little bit more about batch versus real-time change data capture, moving from a batch mode of processing to an event-driven, near real-time mode of doing things, right? This is the way the world is now. You know, I don't care how, but I want it now. Right? I don't want to wait 12 hours or 24 hours to get the result. I want the information now. I'm not going to go through this because it's boring. But there are many benefits to being able to do this. I mean, even with change data capture, for example, you can achieve, real-time integration. A change occurs in your indexed RMS file. Well, that change record is published off somewhere else to some other system that needs that information now, not in 12 hours' time or 24 hours' time, wants it now. This provides numerous benefits. You can read through that later at your leisure. Now, back in 2019, Attunity decided that they were no longer going to support, well, Attunity were acquired by Click, and they decided they were no longer going to support the Attunity Connect and related products, including change data capture, on the OpenVMS platform. They're happy for us to provide level 1 and level 2 support, and Hein van den Heuvel provides our level 2 support with customers who need it for that. But essentially, customers were looking for replacement solutions. So we've kind of been beavering away behind the scenes and working with Hein and with Brian on coming up with a replacement solution. And I've made the bold assertion up there that our solution is going to be as good as, if not better, than the Attunity Click solution. And it's looking pretty darn good at the moment. So the way this works is Brian wrote many years ago originally for Attunity, but it's his software, so there's no kind of legal connotation there. Brian wrote this fantastic little RMS interceptor, right? There is no escape. You can figure this thing up to say, I want to intercept changes from file A, B, and C. You can't avoid that happening, right? It's going to happen even if you don't want it to happen. It's going to intercept those changes, and it writes those changes to something called an RLF file. Now, that's just a sequential file. Oh, what do we have that can read sequential files? Vol. How do we get it to deal with RLF files? No problem. We just write a vol extension that knows what to do with an RLF file, right? So we're just using vol out of the box. That'll be one of my batch jobs finishing. That was generating some load. We just use vol out of the box. We wrote a little shareable image that knows what to do with Brian's RLF files, and it can publish those change records into our message broker. This qualifier here, this map equals cdc.map, that defines how the messages are routed. This gets interesting, okay? So let's say we've got this file here, CP3. Any change record that we get for that file, right, read from the RLF file, is going to be published to an exchange in our message broker that looks like this. Now, this file contains variants. What do I mean by a variant? What that means is there's some field within the file's record structure that determines what the rest of the record looks like. There are many customers that do this to the point of annoyance. And Jeff Murch can tell you about this in great detail. But our little vol extension here for change data capture knows how to handle this. Okay, you can actually say that in this case, at offset 13 within the RMS file record from this file, which Brian has intercepted, at offset 13, size 1 is a string. Well, it's only 1 byte, don't care. If the value of that byte is A, then we're going to route the message differently to if the value is D, okay? So for every record vol gets, it knows how to map it into the message broker to get it into the right queue so that the customer can consume, messages that they want in a fairly flexible manner. So the RMS interceptor, as I say, that's the component that Brian wrote for Attunity and that we are now leveraging in our solution. It intercepts the changes. There is no escape, as I say. It includes some additional information in the records that are written into that RLF file: sequence number, timestamp, process ID, file ID, and the operation type that was performed. And like I say, vol then reads those RLF files. Brian's component is cluster aware, so you can use this solution quite safely in a cluster with multiple nodes all accessing the same RMS files. Not a problem. Performance impact, minimal. Okay, we've achieved the solution I just have described. We've achieved better than 20,000 records a second here. going into the message queue. So this is just obviously the right-hand side of the architecture diagram I had up previously, the change records getting into the message broker. And we have written consumer side as well. It's actually, the consumer is written in .NET, but hey, .NET works on Linux as well as Windows these days. So we're able to consume those change records from the RabbitMQ message broker, transform them into SQL statements, and insert those change records into SQL Server or into Postgres. And so the consumer actually knows what the record format looks like for each of these records. That's described actually in an XML file, if I recall. It does whatever transformations might be required on the data, because obviously these RMS files contain all sorts of fascinating VMS-centric data types. Knows how to transform them, create the appropriate SQL, make it into the database. Okay. So, in summary there, our replacement solution, I think, is coming along very, very well. There is still some work to do. So, you know, could I give you something today? Yes, I could. But we'd probably need to do some consulting or something like that to get it 100% across the line for you. But it's looking pretty darn good. And as I say, be sure to catch Hein and Brian's talks as well, where they will go into more detail on some of this stuff. Now, the tricky one. This may or may not work. Okay, so I've got a demo here where I'm running a simulation program that is performing random operations on something like 309 indexed RMS files, right? It's throttled, it's trying to pretend to be a bunch of users, so it's not absolutely caning the system by doing, you know, thousands of operations a second or anything like that. It's probably only in the tens of operations a second or whatever. But these 300 files are on a small i4 server on the VSI network. There's an assortment of record layouts, very simple simulation, as I say, and all 300 of these files are being monitored by the RMS interceptor. So every time my simulation program does an insert or an update or a delete, Brian's interceptor is going to intercept the change on those files and write a change record to the RLF file. Vol is going to read those changes and going to publish them into a message broker, which is running Cloud AMQP, which is hosted RabbitMQ. This is where I'm getting a bit nervous because that's hosted on AWS. And I'm only going to focus on one file because otherwise we'll be here all day if we look at 300. The consumer is going to consume those records and plonk them into, in this case, we're going to plonk them into a thing called CockroachDB. Now, CockroachDB, aside from having a cool name, CockroachDB is a relatively new relational database, and it is a truly distributed relational database, right? So CockroachDB runs across multiple nodes in the cloud environment. If one of those nodes goes down, there's no data loss. I might notice some degradation in performance or something like that. But it's actually a really good database. And the interesting thing about CockroachDB, as far as this demo is concerned, or the good thing about it, the useful thing about it, is that it speaks the Postgres wire protocol. So when I mentioned on that previous slide that our solution supports SQL Server and Postgres, it also supports CockroachDB. So I thought, why not just really go for broke with this demo, cross our fingers and see what happens. Oh, and did I mention that CockroachDB is also an AWS East? So what can possibly go wrong? So essentially, this is the diagram. This is the schematic for the disaster which could happen here. We can be fairly confident that things are going to work up to this point. We might have an AWS issue here, or we might not. We're then, just to throw another cloud into the mix, a cloud provider called Vultr. That's where we're actually running our .NET consumer, and it's inserting some records into CockroachDB. So let's just see what happens. If we jump out of there for a moment, and I go over here, then what I'm going to do is I'm just going to run this command procedure called simulate, and it doesn't do very much. It just is going to run the simulation, and it's going to do, I think, something like 20,000 changes on those 300 files. Okay, and it'll take about 40 seconds to run. If I jump back in here to my browser, and one or other of these, possibly this one, yeah. So what you will see at the moment, so within our Cloud AMQP RabbitMQ instance, you can see that we've got all these queues, and the queue names kind of marry up with the files. Like there's a file called AX2, a file called AU3, and so on and so forth. At the moment, there are no messages in these queues, but there's clearly something listening because the consumer rate is so many records per second. If there was absolutely nothing in these boxes, there's nothing listening, essentially. If I start the consumer, if I start the simulation, rather. Oh, now hang on, before I do this, the key detail. So if we jump back over here, and we need to go to, what do I need to go to? I need, possibly that one. No, what I need is my cockroach. There we go. Okay, so if we have a look at CockroachDB here, so as I say, this is also hosted on AWS, but it looks like it's alive, so that's a good sign. So I've only got really one database on here, which is this default database, and it's got these tables in it. So let's have a look at this. Now, what I'll do is we'll pick a file, we'll pick file AX2. So select star from AX2. Boom. Yes, right, there's some records in there. Great. What we'll do is we will delete from AX2. Okay, let's just verify that. There are no records. Okay. So remembering that diagram, I'm now going to run the simulation. Like I say, it'll take about 40 seconds or so. If I now jump back over to here and I say have a look at our message broker, you can't see too much happening, which worries me slightly. But there's one that's 0.2 messages a second. Okay, it's alive. So it's not a staggering message rate because, like I say, I'm not actually, my simulation is only really tickling those RMS files. If I now go back over to Cockroach and I say, I don't know if anything's happened yet, I really don't. This is where you cross your fingers. Select star from AX2. Whoa! Okay, so this data, so that's kind of almost an anticlimactic and rather boring end to it, but essentially, and I'm right back at the start, but that's all right. Swing through here to the end, and essentially that's pretty much about it. Gee, did I really create that many slides? So yeah, so magic has happened. It has actually worked. It's gone all the way through. We ran our simulation. It touched those 300 files. Brian's interceptor intercepted the changes, bolded its thing, read those changes, published them to the message broker. Consumer in a different cloud consumed them and inserted the records, the change records, into CockroachDB. So there you have it, end-to-end change data capture. Okay, what else have we got here? So that's pretty much a wrap, I suppose. So we talked about software telemetry and capturing all that useful information that is stored on VMS, either in your own application log files or in system log files and so forth. And we talked about how a tool like Vol can be used to ship that data off of OpenVMS as quickly and as efficiently as possible and put it somewhere where you can do whatever you want to consume that information and load it into your favorite analysis tool, Splunk, Dynatrace, whatever. Okay, Vol is your friend. It's your little furry friend. It was inspired by conversations with customers, as I say. and it includes the facilities that I just demonstrated there around change data capture for RMS files. Okay, so it essentially provides a lightweight agent alternative for OpenVMS-centric data sources. Consume that data, publish into the message broker, allow you to then do whatever you want with that information. You can do some integration with cool stuff like InfluxDB and Grafana and create nice little graphs and so forth. And don't forget about Prometheus. Like I said, VMS SPI actually has a C API built into it that we've ported that allows it to expose many of the metrics it collects during the course of normal operations as Prometheus, so that the Prometheus engine can scrape those metrics and you can display them. I also mentioned that RMS files are used quite widely by OpenVMS users by their custom applications for data storage, and the change data capture solution that we're working on provides a pretty slick way and quite a flexible way to capture changes to those RMS files and do something useful with those changes. Okay, and questions? Gary.
So, well, I think you kind of talked about it a little bit, but in terms of, is that part of VMS, or would it be like something that you get off the silk portal?
Yeah, we'll make it a licensed product. I've been working with Nikita on that. Like I say, I mean, there's still, I would say, a couple of components that we need to build in there just to make it mission critical. So, for example, it didn't handle the AWS outage at all well in terms of recovering and re-establishing the connection. So, you know, basically information was backing up, if you like. And once I manually re-established the connection, it's fine. But I would like to actually incorporate something like that reconnection logic, for example. And also, at the moment, it doesn't keep... It keeps track of where it's up to in the files, but there's a risk, for example, if your VMS system went down or if you shut things down in some funny order or were a little bit brutal at a stop/ID or something like that, there's a chance that you could, say, get a duplicate record or two. It might not start off again in the right place within the file that it's reading from, something like that. So there are one or two areas like that where I'd just like to make it a little bit more bulletproof. And then we'll see. The other thing I would say, though, and Hein's not here to verify what I'm saying, but what you tend to find with things like the RMS change data capture is that every customer situation there is going to be somewhat different. You know, they don't all want the data presented in exactly the same way, or there'll be some other difference. So you know as well as I do that Hein spent many years travelling around the globe, spending a lot of time with customers getting this stuff set up and working, right? So don't expect this to be any different, right? It's not something you're just going to buy off the shelf and go next, and you're up and running. You're going to have to involve us from a services capacity in order to get the best results out of it. Any other questions? Done and dusted. All right, early lunch.